Welcome to Math Mini Lessons. My name is Sarah Fuentes, and in this video, we're going to break down the 8th grade state test. This year, there will be a state test in New York on computers. Last year was the very first time they ever did it, and it was a little surprising for a lot of kids to take a test on a computer. But don't worry, what we're going to do today is we're going to break this whole test into 2 videos. This first one is just our multiple choice questions. And we have multiple choice questions on day 1 and day 2. On the first day, you have 32 questions, and on day 2, you have another 6 questions. So altogether in this video, we're going to go over all 38 questions. Now, each of these multiple choice questions is worth 1 point on the state test. In the next video, I'm going to go over the last 10 questions, which are the constructive response, which will give you about another additional 18 points. So altogether, this whole test will be worth 56%. But most of your points are going to come right here from multiple choice. So what we're going to do, luckily when you're on a computer, all you have to do is pick the answer. You can just hit it. But what I want you to also do is you're going to have scrap paper. Work out the math on scrap paper. So you're going to see me work through different problems. I'm going to share different strategies. Sometimes I'll share more than one because I really want you to find one that makes the most sense to the most people. And if you have a different strategy, please share it in the comments. And if you want to see more questions or get more practice, also put that into the comments. So with that said, let's jump into multiple choice. Being that there are tons of questions here, expect that we're going to take about 90 minutes or so on day 1. So I want to give you that expectation so that when you're taking the state test, you're ready to battle this test for about an hour and a half. It is an endurance test. It is one that we don't want to rush through just to get it over with. So start getting yourself ready to know, hey, this test is going to take some time. It's going to take me about an hour and a half. I will have an opportunity to take breaks, and I'm going to get all the time I need. So if you need more time, you will have it. But there really isn't a benefit to being finished first. Matter of fact, I will say that most of the kids who tend to finish first do so because they don't have any strategy for a lot of the questions, and so they kind of just rush through it to get it over with. I'm hoping that's not you, and that won't be you if you're sitting through this entire video today, because I'm going to share all the strategy you need to kill this test. With that said, let's get started with the first problem. All right, let's go through the first set of multiple choice problems, and this is what we're going to do. I'm going to reveal the answers, and then you can check them off on your page, see how you did. If you got them right, awesome. Skip to the next chapter, which is the next page of the test. If you didn't, stay here so you can watch the breakdown, and we'll do that for each and every page. So here's the breakdown for questions 1 and 2. The answers are A and B. All right, let's do the first breakdown. In number 1, a group of friends went to a movie theater and they paid $15 for each movie ticket. The group of friends shared 1 container of popcorn. Okay, so here, as soon as they're telling me they're paying for $15 for every ticket, but they're not telling me how many, I'm already seeing this as the variable in here with a constant rate, because I know it's 15 for every ticket. And we know that there's a fixed cost, a one-time purchase of popcorn. So I can rewrite this as, well, they're asking for an equation to determine the total cost C. All right, and the number of tickets would be N. So instead of 15X, I can put 15N. So I'm going to write this in this AX plus B equals C form. So we know what our fixed rate is, the $15 per ticket, or the number of tickets is unknown, plus our one-time fee of $8.99 will give us our total cost, and that matches A. Let's look at B. We have a scatter plot here. We want to know which pair of lines could be used to draw a line of best fit. And the best fit line is really just a line that best represents the trend of all the data. So just looking at it, let me get my little pointer going. I can see that the data is generally going up this way. It's pretty much going this way. And my best fit line is one line that's meant to kind of summarize everything. It's not going to summarize it perfectly, but it summarizes it pretty well. So let's look at the first 2 points, and we have 4, 7, which is here, and 8, 4, which is here. So if I drew a line between these 2 points, you can see that that doesn't really represent our line. One, it has a different association. It's trending down instead of trending up, so I can eliminate that. And then the second one goes from 3, 3, which is here, to 9, 7, which is here. So that's these 2 points here. And this generally, like, it's going in the direction. I'm moving in this way. It kind of it's like almost in the middle. So it's a good average. And so let's just keep going just to see. So far, this one, even though we know it's the right answer, this one looks pretty good. But let's see the other ones because we want to check as well to see if there's something better. We had 2, 4. It's kind of high. And 6, 4. So this line, not so much. It's a little higher. And you can kind of see like all these points down here. So I want to lower this line just a little bit. And my last one, I have 3, 2 and 3, 4. Okay, 3, 2 and 3, 4. Well, that doesn't make any sense as a line. This absolutely doesn't. So you can see B makes the best choice. So even though, and let me draw both of them just so you can see the difference. So between 3, 3 and 9, 7. So here is the one we chose versus here was the other line. 2, 4 and 6, 4. Subtle difference. They're both positive in the same direction, but you can see how this line here is much more in the middle, and so it makes a better average. All right, hit pause and jot this down into your notes. Let's look at the answers for 3, 4, and 5. D, A, and B. So check off with your work, and we'll start by going over the first one, which is where we have to determine the number of solutions that exist. So for here, we have an equation, not a graph with lines in it. So how do we know how many solutions? Our options are 0 solutions, 1 solution, or infinite solutions. So what would that look like? Well, here, since we have 2 equations, if there was no solution, we would have something impossible like 4 is equal to 6, and we know that's not true. That would give us a signal if we were doing these equations that there will be no solutions. If I had one answer like J is equal to 8, that would be one solution. But if I had something like 4 is equal to 4, after I worked out these equations, then that would be infinite solutions. So that's what we're looking for. Do we get a statement that's not true? Do we get a statement with one definite answer, this variable is equal to one number? Or do we get a statement where it's just a number is equal to itself, where it's reflective? All right, so let's see what we have here. We have 8j minus 8j minus 4, 8 times j minus 4 is equal to 2 times 4j minus 16. So I'm going to distribute 8j minus 32 is equal to 8j minus 32. So already looking at this, what do you notice? You notice that they're completely equal to each other. And if you were to carry this out, I could already see that because both sides are almost a mirror reflection, this is going to give us infinite solutions. So let's say you keep trying, because I could already see it right here. Let's say you keep trying and you decide I'm going to add 32 to both sides. And now I have 8j is equal to 8j. And now I'm going to divide each side by 8. And I'm just getting j is equal to j. So there we have it. That shows me I'm going to have infinite solutions. No matter what number I put in for j, I'm going to get the same number on the other side. If I put j is equal to 8, 8 is equal to 8. J is equal to 25, 25 is equal to 25. It's infinite. All right, let's go to the next one. Triangle ABC is rotated 90 degrees about the origin, and then it's reflected over the y-axis to form a new triangle. It's A prime, B prime, C prime. Okay. one of the angles of the triangle is 115 degrees. The other angle is 40 degrees. What is the third angle? All right, so at first you're like, wait a minute, it's telling me a lot about this triangle. There's a whole lot of stuff happening that we don't actually need to know. So first we know that we had the triangle. It was rotated. So that's not changing the triangle at all, except it's just changing its position. It doesn't change the angles. And then it gets reflected over. So again, it's a rigid motion. It's just moving it over, but the triangle itself isn't changing. So what do we know about this triangle? We know two of the angles. We know that one angle is 115 and one angle is 40, and we just had to figure out what the other angle is. And we know that all three angles of a triangle equal 180. So we absolutely have enough information just with this to solve this problem. 115 plus 140 is 155. And we're going to subtract 155 from both sides. So C is equal to 25 degrees A. Okay, so I told you there's a lot of extra information we didn't need because all those transformations were just didn't change the triangle shape. It's the same congruent shape. So the angles didn't change at all. All right, let's look at the next one. 2/3 x minus 7 is equal to 5 minus 3/5 x. And we have to make a decision. Do we want to add 7 here to make a 0 pair and leave this number here? And that would mean moving this one here. Or do we want to subtract 5 on both sides and then have to move 2/3 x over? And that's going to give me a lot of negatives. Like if I subtract 2/3 and subtract 2/3 here. So I think I want it the other way around. So let's add 7. And I have 2/3 x is equal to 12 minus 3/5 x. And now I'm going to add 3/5 x to both sides. Here's an easy 0 pair. But we got to do a little bit of work on this side. So 2/3 x plus 3/5 x is equal to 12. I'm going to give myself a line here. Let's just change these fractions to like denominators. I'm going to change them to 15ths and 15ths. Okay. So I'm going to multiply the first one by 5/5. So I get 10x over 15 plus, and I'm multiplying the second fraction by 3/3, and I'll get 9x over 15. All right, now I can add them up, and I get 19x over 15 is equal to 12. Awesome. Now I have to separate this fraction from this number, from this coefficient and this variable. So I'm going to divide by 19 over 15. So that's going to leave me with x is equal to 12 divided by 19 over 15. You see why I gave myself some room here? Because this was a complicated problem. All right, we're going to rewrite this as we're dividing a fraction. So let's turn it to a multiplication problem. 12 times the reciprocal, 15 over 19. Okay, and now for this, I am going to have to use my calculator. 12 times 15 is equal to 180. So 180 over 19. Okay, so automatically, I'm pretty sure that I'm going to have to delete probably C and D. Let's find out how many 19s can go into 180. Divided by 19. And I get 9 of them. So it's definitely going to be B. But let's just make sure we know why. So let's see, 9 times 19 is equal to 171. 180 minus 171 gives me a remainder of 9. So yep, it is 9 out of 19 left. All right, hit pause and jot this one down into your notes. This one was pretty complicated, but we were able to do it by keeping our work super organized and taking it a step at a time. Let's look at 6 and 7. The answers are C and C. Let's figure out how we got those. For number 6, we have 2 points given for M and N, and we need to figure out the distance between them. And luckily, we already have the 2 points. And we know it's a diagonal line, so I can't just count across. So what I'm going to do is I'm going to use the triangle method. By making a right triangle, we can use the Pythagorean theorem to find that line. So just by using this point here, I could say this length, yep, they're going by ones. So 1, 2, 3, 4. And on the other side, it's also going by ones. 1, 2, 3. Oops, I wanted my laser pointer. 3 plus 2 is 5. All right, so we have a 4, 5 something triangle. So I'm going to just put in my a squared plus b squared equals c squared. And we have the 2 legs. 4 squared plus 5 squared is going to give us c squared. 16 plus 25 gives us c squared. 16 plus 25 is going to give us 41. So if I want to know what c is, I need to find the square root of both. So c is equal to the square root of 41, which is c. All right, let's look at this one. And I see, I already see an equation with a rate, and I see a table. So this is probably going to be a comparing rates problem. All right, 2 electricians, A and B, offer pricing plans for their work. Each electrician has an initial fee and a service hourly rate. So there's a one-time fee and then a rate. So this is telling me it's like this form AX plus B equals C, where here we have the rate per hour plus that one-time fee. The one-time fee. And that's going to be our total cost. The good thing is that I could see for electrician A what my rate is $25 per hour. And then the one-time fee is just the $50. I don't see this here though. So let's make it so they both look the same so it's a little easier. I noticed that these hours are going up by 1. So each hour, how much more, if this is a constant rate, how much more is he paying? To get from 130 to 150, he's paying $20 more. From 150 to 170, $20 more. So his rate is $20 an hour. Now we got to figure out the one-time fee. So let's think about this. If we know the rate, so we have 3 hours. So 20 times 3 is 60. What would we have to add to get to 130? We would add a 70. All right. For 4 hours, 20 times 4 is 80. 80 plus 70 gives us 150. 20 times 5 is 100. 100 plus 70 gives us 170. So I think you can see that our one-time fee is $70. So I'm even going to write this equation down. C is equal to 20x plus 70. Now that they look the same, it's easier for me to compare. So let's read these statements. With the first one, electrician A has an initial fee and hourly rate that are less than B. Is that true? So A does not have a rate that's lower than B. So not true. Because the rate isn't lower. The fee is lower, but not the rate. So All right, A has a fee and a rate that are greater. Well, the rate is greater, not the fee. So no. C, electrician A has an initial fee that is less. So yeah, 50 is less than 70. And hourly rate for A is greater than B. Yep, this 25 is greater than 20. So this is the answer. So both statements are true. And for D, we know they're wrong because it says A, the initial fee is greater, and that is not true. So I don't even have to read the rest. All right, hit pause and jot this down into your notes. Let's look at the answers for 8 and 9. We have D and D. All right, breakdown for number 8. Which of these tables does not represent a function? I know a lot of people always use different analogies, like they'll say there's one input for every output. They kind of do that. What really stuck with me, and I'm not saying that what works for other people has to work for everyone. Every time I thought, I'm a very visual person, so I remember I used to do the vertical line test, VLT, and they used to say like, well, if I have 2 points, like I make a line, and the vertical line test is if I were to draw a line down, it would only hit the line one time, and it would fail the vertical line test if, let's say I had 2 points right on top of each other. This would be a fail, because if I have every X, or my input has only one output, has only one Y. So if I have the same X and it has 2 different Y's, then it's going to fail this test. So when I look here, these are, and I look at it the same way, here's my X, here's my Y. All of these, it's okay that my outputs repeat, because if I were to graph these, I would have a point at 1, 2, 3, and 4, and it would just be a line like this. So that's okay for my inputs. Each of my inputs are different and has another output. That's okay. When I look at B, again, you see that these two are repeating. That's okay, because again, all my X's are different and they all have their own answers. So that's okay. Again, because if you were graphing it, 2, 4, 6, 8, I would have points like this, and that's all right. Nothing's repeating. With C, again, nothing's repeating here. That's good. That's a good sign. And each of these has their own numbers. That's a function. That's fine. We're looking for the one that's not a function. So far, all of these are okay. We want the one that's not going to be okay. And with D, I have 2 3s. So here's 2 different X's, and they have 2 different answers. That is going to fail my vertical line test. I can't have a 3 be a 0 or a 4. Because if I were trying to graph that, here's 3, 0, here's 3, -4, it's going to fail my vertical line test. So this is not a function. Okay, and the way I would know is if my input has 2 different outputs, it's a fail. But it's fine if you have the same answers repeated here, as long as this part isn't repeating. If you have other ways that you like to think about vertical line tests or functions and how to identify what's not a function, just put it in the chat, in the conversation. Let's talk about it, because you might have another way that really works for you. This works for me. It may not work for everyone, but I'm trying to really give you another way instead of saying one input for every one output. Let's look at the next one. What is the slope of a line on the coordinate plane that passes through points 2, 2 and -1, -2? All right, so we're going to think about slope, and how do we find the slope? A lot of times people go rise over run, and that just makes us think of change in the y versus my changes in x. So let's look at our y coordinates. I have -2 -2, and I have -1 -2. So -2 -2 is -4. -1 -2 is -3. So because they're both negative, it will become +4/3. Okay, now you may have noticed I decided to use my y2 values first. And some kids always ask, can you do it the other way around? Does it matter? All right, so let's test it and see. Let's see would it have changed anything if we had gone the other way around. So 2 minus -2 over 2 minus -1. All right, so notice here I have, I'm subtracting a negative number, so I'm going to use additive inverse. And so I'm going to turn this to an addition. I'm going to add the opposite, which in terms of -2 will be a +2. And the same thing here, I'm going to add +1 instead of -1. And guess what? You still got 4/3. So guess what? It really doesn't matter if you use y1 or y2. The challenge is, though, this right here, that when we're dealing with negatives, a lot of people struggle to deal with subtracting with negative numbers. And so I think that's kind of why some people go and use the other way. But guess what? You also had a calculator. So you could have done 2 minus -2 right on your calculator and you would have gotten 4. There you go. All right, hit pause and jot this down into your notes. Let's look at our answer for 10A. And just by looking at it, I do notice that we have pi, but pi is on the outside of a bracket. So there's something going on here. Let's read this problem pretty carefully. A sphere has a radius of 4 inches and a cone has a radius of 3 inches, a height of 8 inches. So I'm already thinking volume. Which expression represents the difference in volume? So they're not asking me to solve this. They just want to know which expression can be used to find the difference in volume. Okay, so when I'm thinking of, I'm going to do the volume of the sphere minus the volume of the cone. So you're going to go to your reference sheet, and we know that for volume of a sphere, we have 4/3 pi r cubed, and then for volume of a, and we're going to subtract on the other side, for volume of a cone, we have 1/3 pi r squared and height. All right, so next, and there's a lot of multiplying happening here. There's a lot. Next, we're going to put in these numbers. So we know that for the sphere, my radius is 3, so I have 4/3 pi. And for r, it is going to be times 4 to the 3rd power. Matter of fact, let's just put 4 to the 3rd power like this. Minus 1/3 pi, and our radius here is 3. So 3 squared, and our height is 8. Okay, so here's what we got so far. Now notice, so far this doesn't even match what we have over here. So this is what we have. Looks similar, like I see some of the same numbers, but I notice for each of these, they've all factored out pi. Why can you do that? Because all these numbers are multiplied together. I could have taken out a pi from here. I can factor a pi. Pi is the common factor for both of these numbers. Okay, so I'm going to factor it out, put pi out here, and that leaves me with 4/3 times 4 cubed minus 1/3 times 3 squared times 8. And I can close up my whole thing. Now you notice how it looks a little confusing because I have the two sets of parentheses. That is why they put a bracket there. Okay, now look, you can see how it matches A in the exact same way. I have 4/3 times, here's my radius cubed, minus 1/3 times my radius squared and my height. So then where's the mistake in the other ones? They're real silly. So for here's the one mistake, is that it's 4 to the 2nd power instead of the 3rd. Everything else looks so close. That's the only difference. In C, they squared the height instead of the radius. Same numbers, but they did a different operation with them. And in D, same thing again. They have this going on and they have this going on. So I had the same mistake twice. Okay, but that's it. They weren't, and it's funny because the first time I did this problem, I was actually solving it. And then I was like, oh wait, I did all that work and that's not what they were asking. But there you have it. I think the trickiest part here was figuring out that they were factoring out pi because it was a common factor for both of these expressions. That is why they factored it on the outside. Okay, because then if you want to solve it, you could always distribute it and you would get right back to this original equation. All right, hit pause and jot this down into your notes. All right, let's do 11 and 12. Here's the reveal. B and A. And so far we haven't used our calculator much. Okay, let's go into 11. We're trying to figure out what the N is in the diagram. So what would N and N? So let's start by what we know with these figures, with these over here. I know, let's see. I know that all of these three angles together make up 180 degrees. And there are different things you can see, right? But I'm seeing this line, and I know that if I add this, this, and this, I get 180 degrees. And I also know that this one down here is a right angle, so it is 90 degrees. So I'm going to write an equation, 2n plus 90 plus n plus 18 equals 180. We're going to combine our like terms and put them right next to each other. I like to highlight them so you know exactly how I got them. 2n plus n plus 90 plus 18 is equal to 180. And now I can combine like terms. 3n plus 108 is equal to 180. Now this is something we can solve. We're going to subtract 108 from both sides. And that gives us 3n is equal to 72. And we can divide both of these by 3. That I can use my calculator for. And n is equal to 24. And then you could always go back in and check. All right, so 24 plus 18 is 42. So this angle over here is 42. And 2 times 24 is 48. So if I added all of those together, 48 plus 90 plus 42, I get 180. So we're absolutely right. All right, so the trick of this one was, of course, being able to recognize a combination here with lines that those three angles equaled 180. All right, you can make those corrections and add that to your notes. In the next one, I like this one too. We want to know what x is, and we know x to the third power is equal to 64. So if you haven't memorized your numbers, like I know we've memorized squares, like when we're squaring numbers, but not everybody has memorized our cube numbers. If you're not sure, one thing you could very easily just do is just try the different ones here, because you know this is just going to be x times x times x. Gives me 64, so just try it, and you can just do, all right, 4 times 4 times 4 is 64. Bam, there it is. And you can see this isn't a big thinking things. Like if I tried 8, I would have gotten 512. If I tried 16, I'd get 4,096. And if I try 32, I get even bigger number, 32,768. So what's great about this is that we don't have to have it memorized. We can use our tools to figure this out. And there are other buttons on the calculator for figuring out cube root. But because if you haven't done that a lot of times before, I don't want you to get confused that moment and get frustrated because you can't do it. So I'm just giving you another substitution. You can just substitute for x and see which one works, which one is true. All right, jot this down into your notes. All right, let's do the reveals for 13 and 14. We have A and A. Let's break down 13 first. Kevin and Christy both saved money for their class trip. Kevin saved the same amount every week. The amount that Kevin saved every 2 weeks is shown below. So there's something about this. I want you to think about the difference. If he's saving the same amount every week versus the same amount but he started off with. So this is a nice, easy proportional one because it's the same amount starting with if he started from 0. So I like this one. So y equals, just a nice, easy one. Matter of fact, in 7th grade, you probably knew it like this, kx, where it was just a nice constant rate, just the same number. Okay. Christy's savings can be modeled with the equation y equals 26x, where y is the total amount of money saved in x weeks. Which statement compares the two rates? All right, so Christy has y equals 26x, and we need to know how much Kevin is saving. And this is, again, every 2 weeks, how much is he saving? So I'm just going to subtract 92 minus 46. So that's $46. And let's see if that's consistent here. It should be. 138 minus 92 is another $46. So every 2 weeks, he is saving $46. So that's important. So then how much is he saving every 1 week? He'd be saving half of that. So half of 46 is 23. So that is how much Kevin is saving versus Christy. All right, now we can look to see and answer this question about how much they're saving. So in the first one, it says Christy saves $3 more per week. And that is absolutely true. Christy saves $26 a week. Kevin saves $23 a week. That's $3 a week more. The second one we know is not true. Kevin saves $10 per week more than Christy. Nope. Not true. Christy saves $18 more per week. That's not true. Kevin saves $20 per week more than Christy. Also not true. Let's look at 14, and I see a right triangle, because I see a right angle right here, and I like these because it makes me think of Pythagorean theorem. A window washer leans a 13-foot ladder against the house. The bottom of the ladder is 5 feet from the ground. Look at the diagram. How high is the second floor window? So I want to know this leg right here. Okay. So a squared plus b squared equals c squared. We know one of the legs is 5, so 5 squared plus b squared. And we know that our hypotenuse, our biggest line right here, the one that is opposite our 90-degree angle, is 13. So 13 squared. Let's square these numbers. 25 plus b squared is equal to 169. And we can just subtract 25 from both sides. And we get b squared is equal to 144. So to find b, we need to find the square root of both of them. And the square root of 144 is 12. Not so bad, guys. So hit pause and jot this down into your notes. I love dealing with right triangles. That was the first time I felt like I was doing like grown people math. That's why I get excited when I see it. All right, let's look at our answers for 15 and 16. For 15, we have A, and for 16, D. So check them off, and let's start breaking it down. With 15, this is just like the other one when we want to know, we want to classify the equation and figure out how many solutions it has, 0, 1, or 2. And we did it just like in the very beginning of this test. So I'm going to just start by distributing, and I get 1, oops, there we go, 1 and 5/10 x minus, we distribute 12, is equal to, I'm going to change that 3/2 to just 1 and 5/10 x, just for consistency. You can leave it if you want, but I just would rather have everything be decimals if possible. And now you got to make a decision. Do you want to add 12 and then you would have to subtract here. We'll go with that. So I'm going to add 12 to both sides. Negative 1 2/10 plus 12 is 10 8/10. So 1.5x is equal. My spidey senses are tingling right now. Definitely tingling. See if you can figure out why. Because see if you notice it before I even say it. Just think for a minute. All right. Now I have to. We said we wanted all the x's on the other side, so I'm going to move this. And do you see it? You see it? It canceled out completely, so I have nothing left on this side. 0 is equal to 10 8/10, and that ain't right. That's not true at all. This is not a true statement, so this is an awesome example of no solutions. Let's look at number 16. Triangle ABC is graphed on the coordinate plane. ABC is dilated. So when you're thinking of dilating, think of like an eye, where it can get bigger or smaller. It either shrinks or it stretches. Okay, it's either going to shrink down or it's going to expand. But it's going to be similar, but definitely it's going to change. So we're thinking about this triangle. It's either going to get way bigger or it's going to shrink down. Something's going to happen there. So it says that this one is shrinking by a scale factor of 2. So that means it's going to get bigger. It's going to stretch out. It's going to expand by 2. All right, so we need the coordinates for each one. So what we're going to do is we're going to find each of these coordinates, A, B, and C. And we're going to expand them by 2 using multiplying. So A has points 2, 2. So if I were to dilate this one, my new points would be 4, 4. Because I've now dilated it by a factor of 2. It's gotten twice as, is expanded by 2. It's gotten bigger. For point B, which is at 4, 4, again, I'm going to expand it by 2. So my new B is going to be 8, 8. And C, my point is negative 4, 2. So my new point will be negative 8, 4. And all of this matches D. And so you can see what this looks like. It's just literally, it's going to expand out. So for my new point A, it's going to be 4, 4. Which is actually where B is. B is going to be 8, 8. This is my new B. This is my new A. And C is going to be negative 8, 4. So now my new triangle and you can see how it's expanded out, how it's gotten wider. And there you go. All I did was, if it was a factor by 2, I doubled it. I doubled my X and Y coordinates. Let's do 17, and it's another right triangle. I love those. All right, let's look at this one. We want to know the length of BC. So we want to know this side, which is the hypotenuse. So that's going to be my C. And we can just figure out A and B. So A in this case is 2. So 2 squared. And our B goes from negative 4 to 2. So that's a distance of 6 squared. So 4 plus 36 is equal to C squared. 40 is equal to C squared. So if I want to know what C is, and bam, there it is. I have to find the square root of both. So C is the square root of 40. All right, jot this down in your notes. Let's look at the answer for number 18, and the answer is B. All right, so we have a scatter plot here, a whole bunch of points, and there's already a best fit line created. So a line, I'll just put BFT, best, or BFL, best fit line. The scatter plot below shows the weight in pounds of an alligator as it grows in the zoo. And the line, that's the equation of the line, y equals 0.3x plus 5.8, has been drawn to best represent the relationship between the alligator's weight and growth over time. Which statement describes what this number means? So what does that number mean? Like, what does that slope mean? Well, we know that the x, we know what this means. This is the number of weeks. And we know that this was the starting weight. And this is the new weight. So what does it mean that is growing 0.3? It means that over time, as the weeks go on, his weight is increasing 0.3 pounds. Every single week, it is increasing 0.3 pounds. Okay, so that's how I use both of those. It is increasing 0.3 pounds each week. Okay, and that gives us B, the approximate number of pounds the alligator gains each week. It can't be the starting weight because that would have been 5.8. It can't be the maximum number of pounds he gains because sometimes he's gaining a little bit more, sometimes he's gaining a little bit less. But this is our best fit line, is like an approximation. We talked about that. And it can't be the average number of pounds of food he's fed each week, because although that might be true, that's not what this is really showing. This graph is showing alligator weight. All right, hit pause and jot this down into your notes. All right, let's look at 19 and 20. The reveal is A and A. So we'll start with number 19, which is a geometry problem. It's a transformation. Trapezoid ABC and his image ABCD, our new image, is shown below so I can see them. I see it hasn't changed, so it's going to be some type of rigid motion. When I say it hasn't changed, like the shape of it is the same and the length and width and side, those are all preserved. Its location has changed. That's it. What sequence of transformations could be applied to map our trapezoid to our new trapezoid? So how do I get from here to here? And I do notice, of course, that they're reflective of each other, symmetrical. They're like this side is to the side, this side is to the side. All right, so on the first one, it says a reflection over the x-axis. So it's like, if we went over here and we mapped this piece up here, like that, and then it's rotated 80 degrees. So this is 90 degrees and rotate again to 180 degrees. So that is how I could move this image over. So I'm going to just draw it again just so you can see it. So 1 2 1 2 1 2 1 2, and then I know it went up 1 2 and over. So that's our original. And then if I would have done it just 90 degrees, I would have just flipped this over 90 degrees and it would have looked like slanted this way. And then I would have flipped it over, and that's how I would have got the little slant happening this way. So A is the answer. And this is hard because when it was on paper, you can literally just turn the paper around. So you may want to just draw it out on your own scrap paper. On a computer screen, I don't think you can rotate the page the same way to see it, but sometimes drawing it really helps. So use your graph paper to actually plot the points and try these out. Let's see why the other ones don't work. For B, we have the first step is the same, but then it only rotates 90 degrees. So we go from here, but we only stop here in this quadrant. So that's why that one doesn't work. For C, if we reflect it over this axis, the y-axis, so it goes over here, and then it gets rotated 80 degrees. So that's why, like, if it was just this first step, I'd be like, yeah. But then it does something else. It rotates it and rotates it again. So, nope. And for C, reflection over again. This part is true if it stopped right there, but then they still rotate it 90 degrees. So, no. All right, which equation represents a linear function? And you've seen me write this many times. Ax plus b equals c. This is linear. Same thing as if I just had y equals kx. This would be linear. We can see something might be multiplied, but that's okay. No exponents here. We're good. And the only one that matches that is a, where we have our ax and our constant. Okay, it can't be b because x is squared. That's not going to give us a line. Same thing with c. It can't be c because we have x squared. Again, that's not going to give us a straight line. That's going to change the value. It's going to get bigger really fast. And here we have something going to the third power. So if you notice that, like if you have some your x going to the second, third, or any other power, it's not linear. As long as x is going to the first power, or you don't even see the power, then like here we can't see that this is a power of 1. It's just a number. These will not be linear. Okay, so not linear if you see this, not linear if you see that. Let's do the reveal for 21. The answer is D. So I'm going to focus in on this one here. And what we're going to do is we're going to see a function that has all of these conditions. And the first thing it's really doing is it's going to be splitting up the graph. Because we read it from left to right, we're going to use our x-axis. And it's going to section off the graph into sections based on values of x. I'll show you what I mean. So in the first part, it says it is increasing, let me lower this down, increasing and linear when x is between -5 and 3. So I'm looking at this section. Here's between -5 and -3, this one little part right here. And you can see that it is increasing. But to be fair, that was true for all of them. Between -5 and 3, all of them were increasing. So let's look at the next one. I'll make it pink. It remains constant between when the value of x is between -3 and 0. Okay. So in this little section, from here to here, is constant, meaning it doesn't change. The slope is flat. It just goes straight across. No change at all. So for A, that's true. For B, that is not true, because you see how it curves, and that's why we can eliminate B. But for C, it's true. All right, let's look at the next one, next condition. It is decreasing and linear when the value of x is between 0 and 3. Okay. So here's 0 and 3. So we're looking in here, and you can see, yeah, it's decreasing. So between that section, so do you see how I mean how it sections off using my x values? So for A, that's true. We don't care about B anymore. But for C, it's not true. C is increasing instead of decreasing. So we can eliminate this. And our last one, it is increasing and non-linear when the value of x is between 3 and 5. Okay. And so we can see here it is increasing, but it's a curve. So it's non-linear, it is increasing in that last section versus A, which is increasing, but it is linear. So that's why we can cross that out. So I always like to just tell the story, and I use my little symbol. So here it was increasing. In this section, there was no change. It was flat. And then it was decreasing, and then it was increasing again. But we did also want to say that it was non-linear. And that's it. That's all I did here was just, you just have to know how to read that part when it says when x is between this and this. I can just section that off. You can just section that off on the graph, and then you can see it, and you're trying to think, is that true in this section? All right, hit pause and make any corrections you need to question 21. All right, let's look at our answers for 22, 23, and 24. We have B, we have A, and we have C. Check it off in your work, and stay here if you need to for a breakdown. We'll start with 22. It's a geometry question. On the coordinate plane, triangle ABC is rotated. So it's rotated 90 degrees clockwise about the origin, and then it's dilated with a scale factor of 2, centered at the origin to form triangle, the new triangle ABC. Which statement describes the relationship between the original triangle and this new triangle? So, okay, so two things happen to this triangle. So, triangle ABC, first it gets rotated, and then it is dilated. So I know it's just going to be turned around, like we're going to just rotate it clockwise, like we're going to move it. And then when we're dilated by a scale factor of 2, that means I'm growing it by 2. It's getting larger. It's magnifying by 2. All right, so now let's look at our parts here. So A says they are similar but congruent. That is not true here, because I know they can't be congruent because I've dilated it. It's a scale factor, so that cannot be true. It's going to be bigger. It's going to be twice as big. For B, it says they're similar but not congruent. That is true. So it's still a triangle, and it will still be proportional. It's just going to be twice as big. So this question is really asking, can you tell which types of transformations are going to keep the shape the same, and which one changes the shape in some form? So the ones that will not change the shape, they just change its location. We know their translations when we slide it, rotations when we turn it, or if we like flip it to the other side of like the X or Y axis. Any of those things, we can reflect it, we can translate it. Any of those, it's just moved, but the shape is still the same. The angles are still the same. Every side is still the same. It's just moved locations. But when we dilate an image, now it's still looking the same, but it's going to be bigger or smaller. So that's the difference. All right, so now we've not preserved the image, we've changed it. Let's look at the next one, 23. One of the angles, let me get my highlighter. One of the angles in the triangle measures X degrees. Another angle measures Y. Which expression represents the measurement in degrees of the third angle? Okay, so if we were thinking about this, we know we'd have triangle, we have X, Y, I'll just call this one Z, and we would do X plus Y plus Z is equal to 180. Now, what could we do if we wanted to learn the other angle? Like, let's say we knew what these two were. All I would have to do is I would start from 180, and I could subtract X and Y. So I could just add these two up together, and then I would just take them out of 180, and that will give me my last angle, and that's A. Okay, but look at how that parentheses is super important. Very, very important, because let's say we had some, let's just give ourselves some easy angles here. Let's say X was 50 and Y was 50. Let's just do it easy. So if I had 180 minus 50 plus 50 gives you my third angle. I would go from left to right, and I would get 180 minus 50 is 130. Plus 50, I get 180 again. That's why that's so critical that we have that parentheses. Look at the difference when I put a parentheses in there. Now I'm going to do that. 50 plus 50 is 100, and then 180 minus 100 gives me 80. So that's why A is the answer and not B. And I think you could pretty much tell why C and D don't work, because we can't add or subtract the 180 where they are at the end. That doesn't make any sense. All right, let's look at 24, and it's exponents. So we're going to use some properties with exponents. All right, so we have 7 to the negative 8th power times 7 to the 3rd power. So first I'm going to use the property for negative exponents, which means I'm going to take this 7 to the negative 8th power, and that's going to change to 1 over 7 to the 8th power. All right, so I'm using the negative exponent property. Now I can multiply these two. Times 7 to the third. I'm going to put a 1 as a denominator so I can multiply these two fractions. And I get 7 to the third over 7 to the 8th. So I get to use another property, quotient of powers, which means I can just subtract because they both have to the 7th. They both have the same base here. I can subtract my exponents. I would do 3 minus 8. Okay, so it is the same thing as, oops, got my pen, 7 to the 3 minus 8, which is 7 to the negative 5th. All right, and now I'm going to go back to using our negative exponent rule. I told you I kind of like these. And I have 1 over 7 to the 5th power. So look at these two I have right here. They're all equivalent. So I look to see, and I don't see this one here. At first, I don't see this in any of mine. And I might get freaked out by that. Do not get freaked out. So I looked here, and I did notice that this one was there. Now, if you got freaked out by that, like I don't see it, what you could do is you can also just check the other ones to see which is equivalent. And if you tried that, like with the first one, I would get 1 over 49 to the 5th power. That doesn't match. 1 over 49 to the 11th power, also not equivalent. 1 over 7th to 11th power, also doesn't work. And then if you had done the last one, it would have been the same. 1 over 7 to the 5th power, which would have been equivalent. Okay, but I really, really love exponent rules. They were always a lot of fun. All right, hit pause and jot this down into your notes. Let's do 25 and 26. The answer for 25 is D, and the answer for 26 is C. So check it off into your work. All right, 25, we want to know which equation represents the line shown. So for me to write an equation, I really only need to look for two things. I'm going to look at the y-intercept when x is equal to 0. And I'm also going to look for the slope. Okay, so luckily here my intercept is just 0, so it's just a 0, 0. Okay, so if I was writing my equation, y equals mx plus b, this is just going to be 0, or I might not have anything there. So let's see what our slope is. And just by looking at it, I can see that it's going to be a negative number because it's going down. So how much is it going down? Let's see, and always think rise over run, or y over x. So it's going, find an easy point. Actually, I'm going to use this point here to help me make my triangle. And I'm going down 2 and over 8. Okay, so I went down 2 and over 8. And I can use any points I want because the slope is going to stay the same. It's constant. So down 2 over 8, which I can simplify as a slope to negative 1/4. So that would make my equation negative 1/4 x plus 0. Negative 1/4 x plus 0. And that gives me t. Okay, the only other one that had, none of them had negative 1/4. But we could tell C is not true because it doesn't have a positive slope. So I can get rid of that. Okay, if you had gotten A or B, it's just because you reversed and you did your x over y. So you probably did 8 over 2, which simplifies to 4 over 1. So that was the error for the other two. All right, jot that down to your notes. Let's look at the next one. I think it's going to be a volume problem. Patty has a flower box, as soon as I saw it, in the shape of a rectangular prism with interior dimensions that are 15 inches in length, 8 inches in width and 6 inches in height. So 15, 8, and 6. Patty will fill the volume, the flower box, with 3/4 full of soil. Okay, so not filling it all the way. How many units of soil will be in the box? So my plan is going to be, let's find the volume of the whole box, and then we're going to find what is 3/4 of the volume. Okay, so that's what we're going to do. We're going to find 3/4 times the length, the width, and the height. Okay, and for length we have 15, for width we have 8, and for height we have 6. And we're going to multiply all that by 3/4. All right, 15 times 8 times 6 is equal to 720. So I want to know what is 3/4 of 720. I'm not going to multiply this. I could as a fraction on my calculator, but I already know that 3/4 is the same as 0.75. So I'm just going to do 0.75 times 720. If you want to do it as a fraction, you're going to get the same answer, and you're going to get 540. Okay? Either way, you would have done the same thing. You could have just done 3 times 720 divided by 4. You're going to get the same answer. All right, hit pause and jot this one down into your notes. Let's look at 27 and 28. So we're almost at the end. We're trying to get to number 32 the first day. This is probably when your gas tank is running out of energy. You're getting more tired. And it's really hard to really focus. So if you need to take breaks during the state exam, you have all the time to do that. So you can always take a break here. We're going to start with the first one and show the answer for 27 is A. And for 28, we have C. For 27, we want to know which one of these is equivalent to 3/5. So we're going to do our properties to all of them. I'm going to just split this into A, B, C, D. So I can do my magic. So 3 to 10 over 3/5. 3/15 over 3/3. 9/10 over 3/5. And 9/3 over 9/5. All right, for the first one, we're going to use the quotient rule, which means I'm going to subtract 10 minus 5, and that's going to give me, it's the same base, 3 to the 5th power, which is the same, which is the one we wanted. So boom. So I could completely understand if most people stop there, but if you're here, it's because you didn't see that in the first one, and it's making me wonder, what could you have seen in the other ones that would have given you a different answer? So in the next one, we can see the base is 3, and I could see that some people may have just done 15 divided by 3 to get 5. So if you did that, I could understand you saw a division line and you just did that. That's okay. So now you just know that it's actually subtracting. And the reason why is because 3 to the 15 means I have a whole bunch of 3's being multiplied. And on the bottom, I have a bunch of 3's. And I have 15 and 3 in the bottom. So I can divide. All I'm doing is I'm taking away, like 3 of them are going away. And that's leaving the rest. That's why I'm using subtracting. So I'm taking away 3 sets of 3, but it's leaving 12 more. All right? So that's why it is 3 to the 12th. In the next one, C, the problem is the bases are not the same. So I can't use my quotient rule. Can't use it. I could do 3 times 3 to get 9. So maybe, and again, I'm trying to think, so what could a kid have done? All right, so it's possible that a kid went, well, 9 divided by 3 is 3. And then they use 10 minus 5 is 5. So that could be what got someone the answer 3/5 here, is that they did 9 divided by 3. So I get that, but you can't use that and then use the same, do something with the bases. It doesn't work. It doesn't work here. They have to have the same base for you to use the quotient rule. You can't use the quotient rule after you've done division with the other numbers. Okay, so that's all that mistake was. And these are normal mistakes. With D, what could have happened? 9 over 9, 3 over 5. Trying to think, how could someone, this one just seems like a throwaway. It seems like one that you're not going to get a 3. It's just a random one in there. And it's just clearly wrong. I have the same base, but I'm going to get a negative number. So I'm going to get a 9, and 3 minus 5 would be a negative 2. So this would be very different than all the other ones. So I can apply the rule, but it is not equivalent. So we can cross that one off. All right, let's look at number 28. Ms. Gibson made an initial deposit of $500. So I already see a rate happening here. I already see something that's either y equals mx plus b form or ax plus b equals c. I kind of see that happening. All right, and I can see the initial deposit is 500. So boom, that's my b. Let's keep going. After the initial deposit, she deposited the same amount of money every single month. The table below shows the amount money A she deposited into the account after a certain number of months T and opening it. All right, so we just had to figure out how much, we want to know how much money she's putting in there every single month. So there are two ways I can see us doing this. One is we already know some things here, like with the four months. So we know that it's going to be something like ax plus b equals c. So if I looked at this one here, like I took 4 months. So 4 times some number plus our initial was $500 is equal to $1,500. So I could do that, just pick, and I'm solving now for that missing part here. And I could do that. And I get 4x is equal to 1,000 and x is equal to 250. Okay, and then I can just go back in and write my original equation. And my original equation would just be 250x plus 500 will give me my total amount. Oh wait, but they want us to use certain letters, right? So we want T to be the month. So 250T plus 500 is going to give me A, which is the total amount of money. And that matches C. Okay, so do you see how I kind of just work through that by just figuring out what do I already know in the problem and what are the other things I'm trying to figure out. In this case, we're trying to figure out here what is the rate that we're getting. What is that number in front of the x? That's what we're trying to work out. So that's one way I could see us doing it, just picking 2 points and working it out. Here's another way that could work and maybe makes a ton of sense for you. I can look to see in 4 months, actually let's pick because I can see it's a difference of 4 months. Let's pick an easy one. How about in 2 months? Because here in 2 months, I saw she added $500. So if she adds $500 in 2 months, then that means in 1 month, she must add half of that, $250. And now that I have that, now I can write the rest of the equation. A is equal to $250 a month, so that's T, plus the initial $500. And that's another way to do it. Same thing. And then you could always test it to see if it's true. Like if you did this and you were still skeptical, you could have just picked, all right, let's pick 8 months. 250 times 8 is 2,000. Plus 500 equals $2,500. And in the 8th month, she had $2,500. So we are right. All right, so hit pause. Either one of those ways can work. And if you have a different strategy, a different approach to this, add it to the comments. All right, let's look at 29, and we have a table that represents function f. Oh, wait, let's do the reveal first. Let's wait. Our reveal for this one, the answer is D, so check it off in your work. And stay if you need to for the breakdown. So the table represents function f. And we had an equation for function g. And that is y is equal to 4x plus 2. What we love about this is we can see the rate and we can see the constant. Really hard to see it here in this table. Doesn't mean we can't figure it out. So let's look at it first. Let's see if we can find the rate of change. And here, when my x increases by 2, my y increases by 6. So my rate of change is 6 over 2 or 3. If you want to test it in another one, we can look at this one here. My rate of change here is 4. My rate of change on my y's is 12. So change in y is 12 over 4 or 3. So we absolutely have the rate of change. We know it's going to be 3x. But let's check to see if what the constant is here. So I'm going to draw the same thing here in the bottom. X and y. And we have 4, 6, and 10, 18, 24, and 36. So I'm going to do our rate of change. 3 times 4 plus what makes 18? 3 times 4 is 12, plus 6 makes 18. 3 times 6, and I'm doing that because I have 3 times x. 3 times 6 is 18, plus 6 gives us 24. So far, we seem consistent. 3 times 10 plus 6 will give us the output 36. So we figured out our constant is plus 6. Now it's so much easier to compare these two. So now we can see which statement is true. With the first one, we have the rate of change for G is less than the rate of change for F. So is that true? Is G less than F? No. Because here I have 4 and here I have 3, so that's not the rate of change. All right, for B, the rate of change for G is less than F. We already know that's not true. That the rate of change for G, here's G, here's F. We know that G has a greater rate of change, a greater rate. For C, the rate of change for G is greater, so that's true. And let's see if the because 2 is greater than 9 over 7. No, doesn't make sense. So nope. And for D, the rate of change for G is greater, true, because 4 is greater than 3. Yes, these are comparing the actual rates of change. So that is why D is the answer. Hit pause and jot this into your notes. Let's look at numbers 30 and 31. We have C and B. All right, with the first one, they're giving us some side lengths, and they want to know which could be the side length for a right triangle. So when I look at this one here, we know that this bigger number, these biggest ones, have to be the hypotenuse. All right, so again, I would divvy it up, A, B, C, D. And for A, I'm doing our regular A squared plus B squared equals C squared. So 5 squared plus 10 squared equals 13 squared. 25 plus 100 equals 169. I can just look at that and see that's wrong. We'll go to B. We have 5, 12, and 17. So it's saying 25 plus 144 is equal to 17 times 17 is 289. Yeah, no. We can just look at that and know that's not going to be enough. So those two aren't true. We'll look at C. We have 100 plus 24 times 24 plus 576. We know it's supposed to be 676. 26 times 26 is 676. So there is our answer, C. And if you wanted to try the last one, you would have 100 plus 576 is equal to 68 times 68 is 4,624, which is wrong. Okay, those are not equivalent. Let's go to number 31. And we have yet another part where we're going to section off this function. And we want to know which statement is true about a section of the function. Okay, so we're going to see which one is true. So with A, it says section N is linear and decreasing. Well, it is linear, but that's not decreasing. With B, it is linear and increasing. It is a straight line, so it is linear, and it is increasing. We can see the slope. It has a positive slope, so we're good there. B. If you're doing the next one, Q is non-linear and decreasing. None of those things are true. Q is constant and linear. So those are both lies. Lies. And for D, section R is non-linear and increasing. Well, one of those is not true. It is linear, but they said it's non-linear, so that one's a lie. But it is increasing. All right, hit pause and jot this one down into your notes. All right, we're up to our last one here. We have another scatter plot that shows the relationship between outside temperature and cups of hot chocolate and events. So the answer for this one is D. So check off and see how you did. This was the last multiple choice on day one, but we're going to continue this video and do all the multiple choice together. All right, so we want to know which statement describes the data. So just looking at this, what do you see and what do you notice? Well, I see that our slope is kind of going down. It is pretty linear, but it's decreasing. So there's a negative association because it is decreasing. I see a negative association. Oops, I wouldn't spell association. That means while the temperature goes up, the number of cups of hot chocolate is going down. Okay, so as temperature goes up, the hot chocolate goes down. And I read this from left to right, so that's what I mean by as the temperature increases over time, we can see that the amount of hot chocolate is decreasing. All right, so now let's see which is true. With the first one, it says there is no association between outside temperatures. That's not true. We do see an association because it is looking like a line. It's not random. So that's false. There is an association. For B, there is a non-linear association. So again, our points almost make a straight line. So it is a linear association. That is not true. So let me highlight the words that make this false. So there is some type of connection here. Let's look at C. There's a positive linear association. So the part I have a hard time here is that it's not positive because they're not both increasing. As temperature goes up, the number of hot chocolate sold is not also going up. So that is not true. Which leaves us with D. There is a negative association, which is true. We already noted that between the degrees and the number of hot chocolate. Put this into your notes. All right, so you've made it through the very first day of the test. So if you've done this part, you can hit pause, come back to this video. We're going to go into the rest of the multiple choice when you come back. All right, we have 6 more problems to do, multiple choice, so let's jump in. With 33, the answer is B. So let's see what's true about this function. So we can see the function, and before we do anything, it's so much easier if we can just turn this table into an equation. So let's do that. To do that, we can look to see very quickly if there's a constant rate of change. If there's a constant rate of change, it's going to be linear. So that's the first thing. So if we have a constant rate of change, it is linear. So my x is increasing by 1. And when that happens, my y seems to be increasing by 3. Okay, so we'll go to the next one. When it's increasing by 1, my y increases by 3. And in the next one, increases by 1, y increases by 3. So my rate of change is 3 over 1, or 3. All right, so far we have y is equal to 3x. Let's test it to see if there's any b. That's the next part. So we'll go back, and I'm just going to erase this part for a second. And I'm going to, let's see, when 3, I'm going to put the 3, and I'm going to put the 2.5. So 3 times 2.5 is equal to, I didn't have to add anything, is equal to 7.5. So 3 times 3.5, let's verify this. Oops, maybe I should put in some work. 3.5 times 3 is equal to 10.5. Okay, I didn't have to have anything there too. 3 times 4.5 gave us 13.5. And 3 times 5.5 gave us 16.5. So for all of these, I didn't have to add anything. So there it is. All right, and just again, all I did was I took my rate of change, 3 times x, and that's all I tested, 3 times whatever x was, to see what my output would be. And because it was enough, it didn't change, I didn't have to add anything. There was no other part here. It's just proportional. So now I can look at my statements, and we can look at B first. The function is non-linear. That's not true. We know that it is linear because it has a constant rate of change. So I just dismiss the rest as soon as I find something wrong with the statement. B, the function is linear. Agree. Because the rate of change is constant. Totally agree. Has a constant rate of change of 3. For the next one, C, just wanted to underline that, is linear. I agree, because the y-intercept has a constant value. That has nothing to do why it is linear. Has nothing to do with that. And let's go to the next one, D. The function is non-linear. I already disagree. I kind of want to look at C for a second again, because it's saying my y-intercept is constant. It's always constant when you draw a line, because if I have anything here and I go like this, here's my y-intercept. Yeah, it's not changing. Even if I made something that was like this, okay, I could make one that has only one constant y-intercept. So that just didn't make any sense. All right, that was just nonsense. But we could clearly see as B because it's linear because it has a constant rate of change. All right, hit pause and jot this into your notes. Another geometry one. I like this one. Let's look at number 34. The answer is C. And they're asking which 2 sides are equal in length. So you had the original one. Here was our original F, G, H, J. And then we had our new one. We can see them. We just want to know which 2 sides are equal. Now, honestly, all they did was rotate it. It just rotated over. And you can see which 2 sides are the same. So we have these short sides are the same as these short sides. So you can just see them. Matter of fact, let's even do it another way. So it's rotated at the origin. So here, this one, if I'm just rotating it over and they're being rotated this way, then I know it's going to be from F to G. So I can see the same ones. FG, FG. Okay. And then in the other ones, we can see GH, and you can see GH. H and J, H and J. J and F, J and F. You can see all of them. So now you're just looking to see which one of these are true. So F and G and F and J. All right. F and G, F and J. No, they're not the same length. You can clearly see it. Next one, JF. So this one over here, and HJ. Again, nope. You can see one is bigger than the other. And I like how you're probably also noticing that you're just looking for the same letters. So G and H and G and H, those two are equivalent to each other. And H and G and H and J, no, those are different. Hit pause and jot this down into your notes. Let's do the next two, 35 and 36. The answers are B and A. Check it off in your work. Fast forward to the next chapter. If you have them, stay here if you don't. All right. We have cylinders. We know we're doing some type of comparison with volume here. So let's figure out what the difference is. With the larger can, we have a radius of 3.5. And even though this says 7 as a diameter, it also has a radius of 3.5. And so the only difference here are the heights, 10 and 6. And we're going to do this in terms of pi. So we're going to use our formula for cylinders. Volume is equal to pi r squared times height. And we're going to do the large one. So we're going to do large minus small. So with the large one, we can leave pi. Our r is 3.5 squared times a height of 10. Okay. And then we're going to subtract it from, again, there's pi, 3.5 squared times 6. So already there's going to be some stuff in here that we could see already is the same. All right, so let's do 3.5 times 3.5. And we get 12.25 times 10. And times pi, so that's 122.5 pi minus. And we'll do the same thing on the other side. We have pi, we already know it is 12.25, but this time it's times 6. And we get, actually, let's clear it out, 12.25 times 6. There we go. We get 73.5 pi. And now we just have to subtract. 122.5 minus 73.5, and we're getting 49 pi. And that's it. All right, for 36, we want to see what's true about the equation. So for space, I'm going to just distribute first, and I'm going to get 6x plus 2 is equal to, let's just combine those like terms, x plus 5x is 6x plus 1. All right, just stop and look at this for a minute. What do you see? What do you notice? Just by looking at those two expressions, can that be true? No. So this is my first indicator. There are 0 solutions here. Well, let's say you didn't see it, you kept on going, and you decided to subtract 1. And you got 6x plus 1 is equal to 6x. Still looking at it, that don't look right. That does not look right. Because no matter what x is, if I have one more on one side, it's bigger than the other. I would have an inequality. So also not true equation. But let's say you still didn't think about it, and you then subtract this 6x, and you were like, wait a minute, now I have 1 is equal to 0. And that should definitely be the dawning on you that there is no solution for this one. So the answer is A. Hit pause and jot this into your notes. All right, let's show the answers for 37, 38. You've made it to the last two, D and C. If you have both of these correct, congratulations. You can stop the video now, and in the next video, we'll do the constructive response. And if you didn't, no worries. I got you. We're going to go through this together. So in 37, we want to know what best describes the value of square root of 2. So when I think about square root of 2, I know it doesn't have an even number, because I know like square root 1 and square root 4, this is 1 and this is 2. So I know that square root 2 and square root 3 have to be somewhere between 1 and 2. So I can eliminate A. But I don't have enough information to figure out the rest. So what I'm going to have to do is use my calculator to figure out, well, how much is the square root of 2? Alright, something was going on with that calculator. I was using free calculators online, so I'm going to my other calculator. And square root 2 is giving me 1.41. That seems right. Okay, so now with this, I can definitely see, here's my midpoint, which would be 1.5. My answer would be somewhere in here. So I can eliminate B. So now I have to say, is it closer to 1 or is it closer to 1.5? And 1.4 is definitely closer to 1.5 than it is to 1.0. So my answer is D. Alright, let's look at the very last one, and I have an ordered set of pairs, and I have to figure out which one makes a function. Now remember, when we talked about this before, anytime I have an x, I can only have one number for it, only one value. I can't have an x with lots of different values because it would fail the vertical line test. So that's what I'm looking for. But it is okay if I have the same outputs with different numbers. So I'm going to put all these numbers in place. And I have like -3, 3. I have 1, 1. I have 4, 2, -1, -1. -2, -1, 3, 1, and -2, 3. Let me bring this up for a little bit. And what I'm looking for is, do you notice, do any of your x's, your inputs, repeat? That's the first thing I'm going to look for. And I notice, let's see, I notice here, my -2's repeat, and I have 2 different values. So that's why this is not a function, because I can't have -2 with 2 different values of -1 and 3. So the question is asking me, what pair can I remove? And it's going to have to be one of these. I'm either going to have to remove -2, -1, or -2, 3. And that's why I chose C. So it's saying remove this one. The other ones were okay to leave. All right, and that's it. That's the end of our multiple choice section. Thank you for having the tenacity. I hope you saw this in smaller sections and just chunked this one because it's a very long video. And if there are any questions or comments, any types of questions you really want us to go over, just let me know in the comments. I'm happy to create more videos and make more, to give you the support you need for the 8th grade exam. And if you have different strategies that you want to share, put the number in there and share your strategy, engage with one another. And if you just like this video, thank you. I hope you do. Share it with other people. That's why I do this, to share with other kids. And I hope to see you in our next video, so I can continue helping you with this 8th grade exam. All right, see you next time, Math Marbles. Bye.